Okay, next video is going to explain finding tests and then practicing. Okay, so let's blow this up so we can read together. Okay, so there we go. Okay, to determine the intervals on which the values of a polynomial are entirely negative or entirely positive, use the following steps. So we're finding out whether the function is always positive or always negative on the interval. There's a method. So we find all zeros of a polynomial. Okay, then you arrange zeros from least to greatest, ignoring imaginary numbers. So find all real zeros. Okay, these zeros are key numbers in a polynomial. Use the key numbers in the polynomial to determine the test intervals. Also, what is important is horizontal and vertical asymptotes. Okay. Choose one representative x value in each test interval and evaluate the polynomial at that value. If the value of the polynomial is negative, the polynomial will have negative values for every x value in that interval. So, you test one and it works, then the rest are going to have the same. Okay? If the value of the polynomial is positive, the polynomial will have positive values for x intervals. Let's see what that means. Okay, I'm going to choose this one. We're going to work through this. So this is x squared minus x minus 6. And we're going to just work through it. Okay? So let's shrink that down. Okay. So we have x squared minus x minus 6 is less than 0. Okay. First, we find zeros. Our zeros are going to be x, minus 3, x plus 2. So our zeros are x equals negative 2 and 3. Okay. Now we arrange it in least to greatest. So once you find that, we arrange it and we make intervals with it. Always starting with negative infinity. Then we go to the next one. And this will be closed. Okay. Actually, no. In the first case, we just write them all open because we don't know. Okay. Then negative 2 to 3. Open. And in between 3 to infinity. So notice I put our zeros at endpoint as markers. So we went from negative 2 to 3, 3 to infinity. Okay? Now, to do a test for this interval, we're going to test a number in here. We choose a number. So I'm going to choose negative 3. I'm going to plug this in for x, okay? So what we're going to get is we're going to get, negative 3 squared minus negative 3 minus 6, and this is going to be, we're going to say is this less than 0? So then this is 9 plus 3 minus 6. And that is not going to be less than 0, okay? So then this one doesn't work, okay? This one doesn't work up here. Let's test this one. So choose a number between negative 2 and 3. 0. Beautiful. So we're going to plug in 0, 0, 0 squared minus 0 minus 6. It's less than 0. This works, which actually by nature is going to also say that this probably doesn't work. Let's try this with the positive 4. So we have 4 squared minus 4 minus 6. Is that less than 0? No. So this doesn't work. So then this doesn't work. So the test interval that's actually going to work is negative 2, 3. If you plug in these two endpoints, does it satisfy this? Well, no, because if you plug in negative 2, this is a 0. So this is going to be, plugged in this number, you'd get 0 is less than 0, which is a false statement. And same thing with this. You would get 0 is less than 0, which is also a false statement. Okay? So both of those statements are false. So then these are both open because we can't plug them in. Okay? So it's open if these endpoints don't work for this thing right here. So these are our endpoints, and we keep them open. Okay, let's look at another case. We're just going to practice through a few problems. Get comfortable with it. This video, I'm going to just do one more. Actually, two more. Yeah, two more. Okay. Sorry, I was looking at time, trying to figure out what is going to be reasonable. Let's do one more practice problem. We're going to do it in class 2. So 2x cubed minus 3x squared minus 32x is greater than negative 48. Now I'm just going to move everything over. So we have plus 48 over here. So 2x cubed minus 3x squared minus 32x plus 48. Now, this is one where we would use our our synthetic division to find zeros. So what I'll do here is I use the synthetic division. So if we have P equals what? P over Q, so it's 48 plus or minus 24, 12, 8, 6, 4, 3, 2. That's a lot. Okay. And Q is just going to be 2, plus or minus 2, and plus or minus 1. There's a lot of different options. Let's not try to do too large. So we have 2, negative 3, negative 32, and 48. So normally I would try mine, but I'm going to kind of cheat and look at how the book does it in the sense that save us some time. So we're going to try 4. 4 gives us 2, 8, 5, 20, negative 12, negative 48, 0. Okay, and then this would be 2x squared plus 5x minus 12. Due to the math, 24, you can get 2x minus 3x plus 4. So our answers are, our zeros are x equals, negative 4, 3 over 2, and 4. Okay? So you would use synthetic division, and then after getting our synthetic division, we get our test intervals. We're going to have a lot. So negative infinity, negative 4. Negative 4, 3 over 2, 3 over 2, 4, and finally 4, infinity. Now, the rule with these is actually that it should alternate unless one of these is a double zero. We'll talk about that. So we test this one with negative 5. We'll test this one with 0. We'll test this one with, 2. We'll test this one with 5. So negative 5, we plug it in. This becomes negative. So this is a negative number, a large negative. That's also still going to be a negative. That's going to be a positive. And that's going to be positive. So it's going to be negative 25, negative 300, negative 250. Negative 250 minus 75 minus, which is a plus, 5 times, so 100, 10, 160, and plus 48. Okay, this is still going to be negative because these two added together just don't make up this, so it's still negative. So this is negative, and 0, you plug it in, you're going to get positive 48, so this is plus. And then 2, you plug it in. If you do the math, it actually will follow this pattern. So let's just check if I'm right. So this should be a minus and this should be a plus if I'm correct. Okay, so 2, plugged it in. 2 cubed is 8. 8 16 minus 3 times 4, so negative 12, minus 32, so 64, plus 48. 48 plus 16 is 64, so these three cancel, and then we have minus 12, so this is a negative, and by nature this is going to be a positive, because this is going to be sheerly too positive for either of these two things to overwhelm it, but we'll show. So 250 minus 75 minus, what is that, 150, 160, minus 160 plus 48. So these two added together will still be not enough for this, so then we'll have positive 48. Okay? Okay, so if you noticed, there's a pattern. Once we have a negative, it's going to be the next one positive, the next one negative, the next one positive. And what is our goal? Our goal is to have a positive value. So which two intervals are we going to have? Well, we're going to have negative 4, 3 over 2, and 4, infinity. Now, here's the secret. If this is not just a greater than, if this is a greater than or equal to, that will change these things, okay? Okay? If you have an asymptote, it wouldn't change it. But if it's a 0, it will. It will make it so that that's a closed bracket, okay? Okay. We are going to do rational in class. So what we haven't covered on this video, we'll do in class, okay? So in class, we're going to cover the 3 rational ones at the bottom. So just be prepared. We'll cover the 3 at the bottom, okay?